As we continue studying functions, we'll be combining functions and then we'll be composing functions. Before we do that, let's do a quick review on evaluating functions. I have two functions here, f of x equal to x minus 3 and g of x equal 3x squared minus x plus 1. Okay, recall that if I have this, which is said f of 0, this means that x equals 0 in the f function. So what I'm going to do then is everywhere there's an x in this function, I'm going to replace it with a 0. So that x came out, the 0 went in. I have 2 times 0, which is 0, minus 3. 0 minus 3 is negative 3. Okay. Let's evaluate in the g function for x equal 5. If I can get it to go up there. Okay, we'll do that one in a minute. Okay, I'm looking at the g function this time, and everywhere there is an x, I am going to put 5. So 3 times 5 squared minus 5 plus 1. Okay, you don't need to always put those parentheses, but it helps you to see that that's where x used to be, now it's 5. That was x, now it's 5. Well, order of operations does exponents first, so 5 squared is 25. 25 times 3, that is 75. Let me put that up there for you. Minus 5 plus 1. 75 minus 5 is 70 plus 1. This one is equal to 71. Okay? Well, let's look at it with some negative numbers. Sometimes those negative numbers will trip us up. Let's try that. Let's try f of negative 6. And we'll try g of negative 2. Okay, let's do the f function first. So, x comes out, negative 6 goes in its place. Okay, 2 times negative 6 is negative 12 minus 3. That then is negative 15. Okay. Using negative 2 into my g function, this x comes out, negative 2 goes in its place. That squared is on the outside. When you put this in your calculator, you have to be careful of this negative number. Separate it in parentheses and put the squared on the outside. Okay. Minus negative 2 plus 1. Well, negative 2 squared is 4, so this becomes 3 times 4, which is 12. Okay, minus negative becomes plus positive, so plus 2 plus 1. 12 plus 2 plus 1 is equal to 15. Okay? Well, pre-calculus is an advanced math class, and that means we're going to be throwing some letters in there. So let's see what happens when I replace that x with a variable value. So I'm going to actually put 2a into both of these, and let's see what happens when I put 2a in. So with doing my f function first, I still got that 2 right there. This x comes out, however, and 2a is going in its place. That entire thing right there is going in for x, minus 3. So 2 times 2a is 4a. 4a minus 3. I cannot simplify that any further. F of 2a is equal to 4a minus 3. Okay? Now let's find g of 2a. There's my 3. This x comes out, and, whoops, I didn't take x out. I put it right back in there, didn't I? X comes out and 2a goes right in there in its place. Minus 2a plus 1. I'll separate that in parentheses for you. Okay? Well, I have 3 times 2a squared. Both of these things are squared. 2 squared is 4. A squared is a squared. Minus 2a plus 1. Okay? 3 times 4a squared is 12a squared. Minus 2a plus 1. Cannot combine these because this one has an exponent, a power of 2, and this one does not. That is my final answer. Okay. At g of 2a is 12a squared minus 2a plus 1. Okay, let's make it a little bit more interesting and replace x with a binomial. Bi means 2. This will be an expression that has 2 terms. So let's get rid of that 2a. And I'm only going to put one of these up at a time this time. Give me a little more room. Okay, so now then, I'm going to do f of x plus 1. So, same process every time. There's my 2 from the function. This x is going to come out, and it is going to be replaced with x plus 1. And there's the minus 3. 2 times x is 2x. Doing a little distributive property here. Remember, we have to take 2 times x, and we also have to take 2 times that plus 1. Okay, so 2 times x is 2x, plus 2 times 1 is 2, minus 3. I've still got 2x, no other x terms. 2 minus 3 is negative 1, so I put minus 1 right there. Final answer. F of x plus 1 is equal to 2x minus 1. Okay. Just for the fun of it, let's throw x plus 1 into that other function. I probably won't give you one like this on a test or a quiz, but it's a good practice of our algebra here. We're going to put x plus 1 into this g function. So here we go. Same process. 3. This x comes out, and x plus 1 replaces it, and that squared is on the outside. Minus this x comes out, and x plus 1 goes in its place, and I still have that plus 1 hanging on at the end. Okay, I have to take care of squaring x plus 1 here. Remember that x plus 1 squared is the same as x plus 1 times x plus 1. Okay? So here we go. 3 times x plus 1 times x plus 1 is x squared plus 2x plus 1. Trust me, you can pull it out, but that's what it is. Minus x plus 1. Okay. 3 times x squared is, let me put the little loops on there. I'm multiplying times this, and times this. 3 times x squared is 3x squared. 3 times positive 2x is 6x, so plus 6x. 3 times 1 is 3, so plus 3. Now, we have to distribute this negative right here to each of these also. So this becomes minus x, this becomes minus 1, and then plus 1. Ooh, I see something nice happening there. Okay, so 3x squared. I have no other x terms. Let's highlight those like terms. Okay, I have 3x squared. There is nothing else like it, so it stays alone. I have an x term right here, and I have an x term right here, so I'm going to be combining those. And then I have 3 is a regular number, minus 1 plus 1. I bet you can figure out what's going to happen to those. Let's simplify this. 3x squared. Then I have 6x minus x, which is positive 5x, so plus 5x. Okay, these two cancel each other out. Okay, and then I just have plus 3. Final answer, 3x squared plus 5x plus 3. That would make an awesome bonus question. And that is evaluating functions. Next up, combining functions.